Hello class, we are in section 9.2 and we're going to look at how to test the mean when the standard deviation is known, and we're going to focus on a right tail test. I will be going through the textbook to go over some of these problems, so it's very important that you have your textbook out. Also, it may be wise for you to go ahead and open up the Desmos scientific calculator, or if you have your TI calculator, you can go ahead and take that out as well. I'm on textbook page 421, and I just want to review over the null hypothesis H0 and the alternate hypothesis H1. We know that the null hypothesis is the statement that is under investigation or being tested. The null hypothesis represents statements like no effect, no difference, things haven't changed. The alternate hypothesis is a statement that is strongly against the null hypothesis. So it wants to reject the null hypothesis. Very important that you know those vocabulary terms. On page 422, you have the types of statistical tests. We're going to focus on the right tail. The right tail says a statistical test is right-tailed if H1, that's our alternate hypothesis, states that the parameter is greater than the value claimed in H0, our null hypothesis. A left tail, H1 will be less than H0, and a two tail, the H1 will be not equal to the null hypothesis. But we want to focus on the right tail. P-value, make sure you read that on page 425. Very important. It says the smaller the p-value computed from sample data, the stronger the evidence is against the null hypothesis. So make sure you lock in the vocabulary term p-value. The level of significance is on page 426. It says the level of significance, which is noted by the alpha symbol, is the probability of rejecting the null hypothesis when it is true. This is the probability of a type 1 error. And on table 9-2 on page 426, you have the type 1 and type 2 errors. So remember that the level of significance is the probability of rejecting the null hypothesis when it is true. And when we are looking at these different types of statements, we want to assume that the null hypothesis is true. On page 428, you have the procedure on how to conclude a test using the p-value and level of significance. It says if p-value is less than or equal to our level of significance, we reject the null hypothesis and say the data are statistically significant at the level alpha. If p-value is greater than alpha, and that's our level of significance, we do not reject the null hypothesis. So if the p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. And again, the alpha symbol represents the level of significance. Very important. Now, we have kind of went over the vocabulary. So now let's go to page 437 in our textbook. And let's look at the procedure of how to test the population mean when the population standard deviation is known. You have this scenario in front of you. Very important that you read this to yourself. And I want to point out a few key points in this question. Some points I want to talk about is it says the mean monthly account is greater than $70. Very important that you lock that in. The mean monthly account is greater than $70. It says the random sample of 200 monthly accounts. So we know that N equals 200. It has a sample mean account of $74. Very, very important. And then it says it has a normal distributed with a standard deviation of $30. And it has a 5% level of significance. So I see several key points here. I see a mean monthly account greater than $70. I see the random sample is 200. The sample mean, so if that's our sample mean, then we know our population mean will be 70, where our sample mean is $74. So make sure you pay attention to that. And our standard deviation is $30, and that is our population standard deviation. And we have a level of significance, which is 5%. We will look at our tables, our graphs in a while, and we will talk about that conclusion. But let's go ahead and start on our work. The first step on page 437, look at our procedure. The first step says, in the context of the application, state the null and alternate hypotheses and state the level of significance, alpha. Very easy. We want to talk about our null. H0 is the null hypothesis. And it's going to have a population mean equals 70. So the null is pretty easy to identify. You just take whatever that value is, and whatever our population mean is, we take that value and set it equal to that number. Just make it equal. And that's it. Our alternate hypothesis is the information that was given in our reading. If we go back to the reading, it said that the mean monthly account is greater than $70. So that lets us know that our alternate hypothesis is the mean is greater than $70. And our level of significance, we already identified that, is 5%. I want to go ahead and convert that to a decimal, which is 0.05. So make sure you understand step 1. It says state the null and alternate hypotheses and state the level of significance. In our reading, it says the mean was greater than $70. That's how I have my alternate hypothesis. And for our null, we just take whatever that value is and set it equal to the mean. So our mean is 70. And our level of significance, which was given in the reading, was 5%. So we are done with step 1. Let's go on to step 2. Step 2 says use the known population standard deviation, the sample size n, the value of x from the sample, and the population mean from the null hypothesis to compute the standardized sample test statistic. So we're going to look at our standard test, our sample test statistic. That formula is Z equal X bar minus mu divided by my sigma divided by the square root of n. Let's identify what is what. So we know that our mean value, our sample mean, is 74. Our population mean is 70. Our population standard deviation is 30. And n equals 200. So go back here and look at the word problem again. And make sure you can identify everything. It says mean monthly account is greater than $70. So we know that our null hypothesis was mean equals 70. It says a random sample of 200. So n equals 200. It says a sample mean So the X bar was 74. And then it told me the standard deviation is 30. So we know that sigma was equal to 30. And I got all this from just reading the question. Now, since we have everything identified, we can now substitute it into the formula. I have 74 minus 70 divided by 30 divided by the square root of 200. I want to use the Desmos scientific calculator to input this information. So I'll go back and forth. So, very important that you use parentheses, because if you do not use parentheses, you're going to miscalculate. So definitely use parentheses. We're going to say parentheses. We're going to take our sample mean, which is 74, minus our population mean, which is 70. And your population mean is also found where your null hypothesis is located. Close that parentheses, divide. Now this part is very important, because if you don't put parentheses around the denominator part, it will give you an incorrect value. So you must put parentheses around here. So definitely test that on your own to see how did the answer change. Very important you put parentheses in this denominator part as well. Our population standard deviation is 30 divided by the square root, and n is 200. Then you can close that parentheses. And as you can see, z equals 1.886 rounded. Very important. Let's write that down. So my z equals 1.886. Now, we do need to find our p-value. Let's go to step 3 though. Step 3 says use the standard normal distribution and the type of test, one tail or two tail, to find the p-value corresponding to the test statistic. So we have already identified that it is a right tail. So if you turn back to page 422, we know that this is a right tail because my alternate hypothesis, which is H1, states that the parameter is greater than the value claimed in H0. Okay, so that's how we know that it is a right tail. So that will be considered a one tail test because it's a right tail. And if you go back and look at the graph, I can see that it is a right tail because we can see our data on the right hand side of our curve. Now, I can go to my p-value generator. This is a very good good website to use. Just Google p-value generator and click on the very first one, and you should get this information. Make sure you select the correct score. I want to look at the information based off my z-score. So if you notice, I already put some information in already. Notice that I typed in my z-score, which I had calculated already, which was 1.886. My significant level was given information, which is 5%, which we know we converted to a decimal already, 0.05. And we've already said that it is a one tail. And then you just click on the calculate button. And it will give me my p-value. The p-value is 0.029647. So very easy way to identify the p-value. So the p-value is, and I'm going to round it a little bit, 0.029647. 0.03, and I just rounded off my answer. As you can see, you have 0.029, and I just rounded up to 0.03. Okay, so now we have completed step 4. We have found our P. We have completed step 3, found our p-value. So step 4 says conclude the test. If P is less than or equal to my level of significance, then we reject H0. But if the p-value is greater than our level of significance, then we do not reject H0. So let's plug it in, and we're going to plug into both parts and see if we reject or do not reject that null hypothesis. My p-value, I have 0.03, and I want to see if it's less than or equal to 0.05, and that is my level of significance, that 5%. Is that true or false? We want to see. And then we're going to take our p-value again. And if your numbers are very close, then definitely write out more decimal places if your numbers are very close to each other. That way you'll know how to answer that question. Is greater than 0.05. So definitely look at this like money. If I look at my p-values, it's like saying I have 3 cents. And my level of significance is like saying I have 5 cents. So if you look at 3 cents and 5 cents, that'll help you understand how to look at this information. Also, something that you learned back in middle school, elementary school, high school, remember that the alligator eats the bigger number. So that's something to think about too. So those are ways to make sure that you're reading the information correctly. So is 3 cents less than or equal to 5 cents? Yes, it is. Is 3 cents greater than 5 cents? No. And it is not money, so make sure you understand that. This is a p-value and a level of significance. So, but sometimes if you tie it into a dollar value, it makes more sense to read the numbers easier. So that's just an example, but it's not 3 cents and 5 cents. So I definitely want you to know that. Okay, so since we have concluded that the p-value is less than or equal to the level of significance, which was 5%. So what does this mean? So what this means is that we are to reject the null hypothesis at the 5% level of significance as P is less than or equal to 0.05. Very easy to look at. What is our step 5 says? Interpret your conclusion in the context of the application. So let's see what this means. So what it's saying in our conclusion is saying that there is enough evidence at the 5% level of significance to suggest that the mean monthly account is greater than $70. You also, there are other ways you can look up this information as well. You can look at your normal distribution table to find the information that you need, and you can also calculate your p-value from looking at it there. So I do want to kind of look at the normal distribution table to also show you how you can find your p-value. But the p-value generator is great because you can type in what you need and it'll give you that p-value. But if you can't do that, then look at the table as well. Okay, so if I look at the table, and your normal distribution table, you need to go to the back of your textbook, to the appendix on page A9. Go to page A9 in the back of the book and look at your normal distribution table. So you have the area of a standard normal distribution. Now, let's look at this table. So remember, my z-score is 1.886. So I need to find 1.886 on my table. Okay, so we're going to go to 1.8, which is here. And we need to go to, we want to get as close to that value as we can. If I go to 0.09, it's right there. So I can pick, if I just go across and down, I'm at this value right here. Okay? So the value I'm looking at is the 0.9706. Now you have to remember that this is right tail. And you have to remember that a normal distribution, it looks at the information on the left-hand side of the graph. And if you can see right here, this is the right-hand side of the graph. So in order to find out what the p-value is, I have to say 1 minus 0.9706. And when I round everything off, I'm going to get approximately equal to 0.03, which is my p-value. So remember that when you're looking at a normal distribution, that it's looking at the information on the left-hand side of the graph. So if you end up getting data that's a right tail, then you have to say 1 minus that number to get that p-value, which as you can see on the image is 0.03, which is what we have right here as well. So that is it for calculating how to test the mean when the standard deviation is known.